Right, back in another of the OMG, it's core chemistry, and today we are looking at calculations. These calculations are a little bit more complicated. They tend to come up on higher papers, a little bit more difficult than the previous video we did on calculations. So first off, calculating the mole or using the mole to calculate. The mole is a way that scientists use to measure how many molecules are reacting with each other. Masses of atoms are so small, so it isn't helpful to try to use grams or try to count the atoms. So the scientists use the mole. Okay, the equation for mole is mass over number of moles times by relative formula mass. If you wanted to remember that, put it in a triangle, it would be mass over Mr. Mole. So imagine there's a big mass standing on Mr. Mole. Okay, so circle the elements and their numbers. This is the question that we've been given to practice. You have 32 grams of lithium oxide, so lithium oxide. How many moles do you have? So trying to find out the mole. So if I cover the mole, I want to do mass divided by mR. So mass divided by mR. I know the mass because it's 32. To work out the mR, so lithium, there's 2 of them. Oxygen, there's 1. 7. So that would be 14, 16. Add them together, so 0, so it'll be 30. So you do 32 divided by 30. Okay, there's a hint here to make sure it's always in grams. So if that was in kilograms, make sure that you convert it to grams. Plot that in your calculator. So it gives you an answer of about 1.06 recurrent, so it's 1.1, and that's measured in moles. Okay, easiest way to do this is to remember the triangle and then just cover up what the question's asking us to identify. Next up then, calculating reactant masses. Again, an equation that you have to learn, okay? So, and you might have to rearrange it as well. So you've got unknown mass equals known mass divided by the total MR times total MR of known substance. So what you might find easier is it's the unknown mass divided by unknown MR equals known mass divided by known MR. Okay, so highlight the key compounds in the equation. So we have got how much hydrogen is produced by the breakdown of 6 grams of water. Okay, so we have got water by here, hydrogen and oxygen. Okay, so if we look at this, we want to work out how much hydrogen. So we don't know the mass of hydrogen, but we know the mass of water. Okay, we can then work out the MRs. So work out the MRs of water. So 1 water would be 18. You've got 2, so times it by 2. So that would be 36. And then hydrogen, each hydrogen's 1. So you've got 2 hydrogens there. That would be 2 times it by 2. That would be 4. Okay, so there's the mass of each of them and the MR of each of them. Okay, so we know the mass of water and we know the MR of water, so we can just put them in our equation. So we know the mass is 6. We know the MR is 36. We have no idea what the mass of hydrogen is, so we put that as 0. Oh no, put that as X, sorry, put it as X. And then we know the MR is 4. Okay. So this is the equation that we've got here, okay? So we need to rearrange it slightly. What I'm going to do is bring up the 4. So it'll be 6 over 36 times by 4 equals X, which is our unknown mass. So input that into your calculator. So the answer you get then for X is 0.6 grams. So that's how much hydrogen is produced when you break down water, okay? You need to unfortunately remember that equation and be able to input values. This is why it's a higher calculation. And then finally, calculate an empirical formula. This is near enough an AS level topic, okay? So I'm just going to run through it to have a go. Sometimes they say calculate the simplest formula, okay, of a compound is the simplest whole number ratio of each atom. So the first thing you've got to do is write down the elements that you've got. So we've got sulfur and oxygen. They said that they had 32 of sulfur and they said they had a total of 64. So take away the 3.2 and that would give you 3.2. Write down the AR values, which is their mass numbers. Okay, and then you do their mass divided by their mass numbers to essentially work out the number of moles. So this one's 0.1, this one was 0.2. Divide by the smallest, whichever number you got was smallest, and then in this case it was 0.1, so you do 0.1 divided by 0.1 is 1, 0.2 divided by 0.1 is 2, and then you work out the formula. So it says we've got 1 sulfur and we've got 2 oxygens. Okay. Sometimes they'll then go on to say it's got a molecular mass of something. So say it's got a molecular mass of... So it said that it's got a molecular mass of 192. What is its molecular formula? Okay, so empirical formula is the simplest whole value. Molecular formula then would be its actual formula. So what you've got to do is work out the MR of that, which would be 64, and then do whatever your molecular mass is divided by 64. That equals 3. So technically you have to times all the values by 3, so it'd be SO3. 0.06. Okay, that's the molecular formula, the actual formula. So sometimes they'll ask you that. If any of these numbers come out as a half, if any of these numbers come out of a half or not a whole number, you've got to double everything. So say that one came out as 3.5, you double it, so it would be 7. Okay, you cannot leave it as 3.5. Right, have a go at these questions, pause the video, and then we'll go through the answers. So what is the equation for working out the mole? I would do mass over Mr. Mole. So then you know them two are divide and them two are times. Why is mole useful? Because atoms are so small, the mass is so small. It's an easier value to use. Calculate the number of moles in carbon dioxide in 22 grams of CO2. So we're trying to work out the number of moles. So cover the moles and we'll do mass divided by MR. Mass over MR. The mass is 22. Oxygen 16 times by 2, that's 32. Plus carbon, which is 12, so that would be 44. Put that into a calculator. So it would be 0.5 moles. What is the equation for working out reactive masses? You do unknown mass over unknown MR equals known mass over known MR. Okay. Calculate the mass of Fe that can be extracted from 8 grams of Fe2 in a reaction with carbon. Okay. So let's move that out of the way a little bit. So we've got Fe and we've got Fe2O3. So mass and then MR. The mass of iron can be extracted from 0. So we know that's 8. We don't know that one, so make that one X. The MR of iron. So the MR of iron is 56. There's only one iron. Then we've got to do, so we've got Fe2 times 56, and we've got O3 times 16, and we've got to add that all together. So just working out the MR over here. So if you times 2 times 56 gives you 112, 3 times 16 gives you 48. The total then would be 160. So that's 160. Thinking about our equation, we don't know a mass, that's X. We know the MR is 56. We know the known mass is 8. We know the MR is 106. If I bring that one over, it's divide on this side, so it'll be times on this side. So I have got 8 over 160 times by 58 equals X, which will be our unknown mass. So plot that all into your calculator. So X equals 2.8 grams. So that's how much iron can be extracted from 8 grams of iron oxide, which is quite good. What a sample of oxide of nitrogen is found to contain 34 of nitrogen. What's its empirical formula? So we've got Fe and O, so we're assuming it's just oxygen and nitrogen. We know it is, why have I written? Sorry, I'm on the last question. That's nitrogen. Okay, so we know that it contains 30.4. Sometimes they give you percentages, sometimes they give you masses. So then do 100, take away 30.4 to work out the percentage of oxygen. So that's 69.6. We then divide them by their mass numbers, which is 14 and 16. Okay, so divide them and then you get 4.35. Then divide by the smallest, the one for nitrogen is smaller, so you do 2.1 and 2.2. That will give you that. So with rounding, because you could round that to 4.4 to make your calculations easier, that would be 2. So that means you've got 1 nitrogen and 2 oxygens, and that's the empirical formula. How would you work out the molecular formula? They have to give you its MR. So they might say the MR is like 100, I'm not sure what the MR is. Work out the MR of that, divide them, and it should give you then a number that you can maybe times it by, such as 3. Okay, this is most probably one of the hardest things you're going to have to do. It's very mathsy, but there's marks for in year 10 and in year 11, so it's quite important. Obviously, have a go. If you're still not 100%, please come see me, rewatch the video, so we can make sure you get all the marks for this.